Let's get started with our next keynote. Today we have with us Yosi Shavit, Head of ICS Cybersecurity Department for the Ministry of Environmental Protection. Yosi will be talking about hazardous materials, new cyber methodology to protect factories. Please feel free to post any questions you may have, and we will do our best to answer them before the session ends. So I hand over now to you, Yosi. Good afternoon, Yosi. How are you?
How are you? Hello, everyone. Thank you, Cybersecurity Observatory, and especially Jose, for inviting me to this session. I'm very happy and proud to be here. Today, I will talk about new cyber methodology, how to defend actually hazardous materials factories in Israel.
Okay, so Yosi, so thank you very much for sharing this knowledge with us, and more importantly, with the global cybersecurity community. I know that you have been working on this for over 4 years, so I think it's a very important topic. Some people might argue that this is not strictly connected to cybersecurity, but yeah, I think it's super relevant. We are seeing high-profile attacks, on critical infrastructures, and we see that the criminals are very active right now, trying to wreak havoc in our societies. So I think, hazardous materials, are a weak point in our society's attack surface. So please go ahead. I hand over the floor to you. Just share with us your presentation.
Thank you. Can you see the shared presentation?
I can see it perfectly.
Okay, as you said, it's very unique and important issue. As much as I know, is the first in the world which deals with hazmat industry. I don't know if there is another one, and I will talk about it. First, I will introduce myself. Okay, so a little bit about me. I have a BSc mechanical engineer from the Technion Haifa, Israel, MBA, some certification from ISACA, and I also lecture in the academic track at Ahba College. I have more than 25 years experience of information security and cyber security, IT and OT. A lot of hands-on experience, a lot of consulting experience, and currently I serve as the head of ICS Cybersecurity Department at the Ministry of Environmental Protection, and I instruct and control and regulate over 4,000 plants in Israel, which hold hazardous materials. So let's start. As Jose told before, many people ask me, what is the connection between Ministry of Environmental Protection and cyber? You like to hug trees, you cleaning the beach, the shores, you grow the flowers. What is the connection with cyber? So if you take a look at this article from February 9, 4 months ago, about 4 months ago, hackers broke into water treatment facility in Florida. They actually increased the amount of sodium hydroxide in the drinking water 10 times than the required value. It's directly damage to public health. We can go back 1 year ago in Israel. Iran tried to increase chlorine levels in the water, in the drinking water in Israel. The hackers done very easy work. They went to the Shodan site, internet site, and they just pick some IP addresses of controllers in water plants in Israel. That's it, very easy. And that was 1 year ago. Last month, some other speakers talk about it, Colonial Pipeline. That's right. The attack was on the IT network, but Colonial Pipeline reported that they shut down the pipeline as a precaution. Precaution because they're afraid of further attacks on the OT system. And when they said further attacks, they meant hazardous materials attack. They meant maybe fires, explosion, all over the places. If you want some more issues for the connection between cyber and the Ministry of Environmental Protection. So if you hack into ERP system which located in the IT network, you can damage the production system. You can change the composition of materials. You can involve in the storage and inventory management. You can send hazardous materials to the wrong destination. You can send fertilizer to pharmaceutical factory and vice versa. You can change the formula in the computerized process. For example, you can get different medicine that you expect because the hacker took control over the production. You can, if you hack into ICS system, you can change pressure, you can change temperature, you can raise it, you can control the flow rate, maybe pH value. And if you, for example, if you raise the pressure too high, you can cause ammonia leakage. Ammonia is dangerous gas. And if you control the HMI station, the human-machine interface, you can send commands to the ICS, Industrial Control System, and from here you can result great damage to environment and public health. So now you understand the connection. In our regulation, we control and instruct over 4,000, to be accurate, 4,262 businesses. You can see here the list from the hazardous materials industry through Water Corporation. We have HCl, it's acid, very dangerous acid, and NOH is very dangerous base. So we can find it in Water Corporation, in water treatment plants. Israel Electric Company, they have flammable materials and they get toxin permits from the Ministry of Environmental Protection. Of course, seaports and airports, a lot of transportation of hazardous materials, for example, chlorine and bromine, and the ports in Israel, Haifa and Ashdod is near population. Very dangerous business. We're talking about pharmaceutical industry, pesticide industry, we have fertilizer, the explosives. In hospitals, for example, we have ETO, ethylene oxide. It's a very dangerous material to sterilize medical equipment. It's controlled by controllers and HMI stations. In swimming pools, we have two materials, hypochlorite and salt acid. If they touch each other, they can get a reaction. In this reaction, free chlorine is free out, and it's very dangerous for public health. Wineries, sulfur dioxide for the preservation of the wine. It becomes sulfuric acid in contact with the air, so you can get acid rain all over the place. And I know some wineries near schools in Israel. Also defense industry and semiconductor industry, we have a lot of toxin gases over there. So we have three main scenarios in our business. Not money, not business continuity, but first one, dispersion of toxins, I mean gases, and we measure it by in ppm unit. ppm is part per million parts of toxins in the air, in million parts of air. The second is the effect of burning flammable materials. We measure it in kilowatt per square meter. We're talking about radiation that can damage, that can harm public health, radiation and heat, and of course, smoke. And the third one is the explosion effect, bar. We measure it in bar or PSI. You will see all this scenario in the cyber guide that I will talk immediately. If you remember 2020 Beirut explosion, everybody remember it. We have all the three. We had ammonium nitrate material, very, very dangerous explosive materials. And we had all three scenarios. We had toxins in the air. You can see here the toxins. We had radiation and we had pressure from the explosives. And we had 170 dead, 6,000 injured, 300,000 homeless, damage to tens of kilometers away. Then the government of Beirut estimate the blast damage in about $15 billion. So that is the connection. So what do we have in ICS, Industrial Control System? We have all these devices from HMI station through PLC controllers, field devices. We're talking about pressure regulator, electronic faucets, heaters, so on, and sensors. And all these devices control the hazmat. And here, sitting very quietly, the hacker. Of course, we have connection between all these systems. We have the commands from HMI station to PLC controllers. We have indications from the sensor to PLC controller. And we have a network connection between all devices. Maybe it's Modbus, TCP Modbus. It's very, very not protected protocol. Maybe other protocol. And the hacker sitting here and waiting for his chance to do hazardous material event. If he controls the HMI station, he controls the hazmats. If we look at a typical factory, you have two networks, OT networks, the red one, the purple, the orange one, and the IT network, the blue one. And we used to think that we have just only one vector attack, right? From the IT, of course, if you download a malicious file, if you click a phishing link, if you browse malicious site, you want to buy flight tickets in a compromised site. But last year, we noticed that hackers can attack directly our PLC controllers that open to the world. You can find it in a Shodan site that I showed before. But we have another vector attack, the most dangerous attack, the inside threat. And we're talking about human resources. We have two main aspects. The first one is awareness, of course. They can do a lot of damage if they don't have cybersecurity awareness. But the other one is the most dangerous. This granted worker that wants to make damage, very big damage to his factory. And these are the vectors, the attack vectors. So you see all the threats, and our goal in our cybersecurity unit is to increase the cyber resilience to these factories in Israel. So we brought two important news last year. The first one is new cyber regulation, very unique on the hazardous materials industry. And the second is new cyber methodology that I will talk about now. The first plant in Israel received additional cyber condition in its toxin permit last year. exactly by coincidence, June 8, 2020. Today we are June 8, 2021. So it's 1 year ago. Since then, we add 60 plants, more 60 plants in this regulation, and it looks very good till now. The regulation is imposed by toxin permit, a mechanism called the toxin permit. We divide the factories into 3 groups, A, B, and C. Group A have to renew this toxin permit every 1 year. And it's based on this toxin permit regulation based on National Hazardous Materials Law since 1993. Okay, we can talk about the new methodology now. Cyber Guide. It took to me about more than 4 years, 4.5 years of hard field work in the factories, and we developed this Cyber Guide from the production floor, not from copy paste from internet site, but from the production floor. You can see it here. And it includes all you need to protect the factories, the hazardous materials factory. It includes the risk assessment, how to do risk assessment in hazardous materials industry, the stages needed to work plan, a list of recommended control, and many appendices. And at the request of the OECD organization, this guide has been translated into English. You can have it. You can have it. I share it for free. You can download it here from this link. You can just send me mail and I send you the PDF. No problem. And I can explain every page that's written here. You can call, you can mail me, and I explain. So the CEO asked himself, what the hell do I have to do in order to increase my resilience in cyber? What do I have to do? So we just planned work planning for him, which include 2 stages, but 7 sub-stages. The first stage include 3 stages that will take 12 months, 1 year, and they have to do first to map dangerous process and risk, then to do cyber risk assessment with our cyber guide, with our instruction, and then classification of ICS system. They will know the requested controls that they have to implement, and if they know the existing control that they have already, so they can go to next stage to gap analysis. They can do the gap analysis, and from the gap analysis to build work plan, what to do, and then the next stage to execute the work plan, and all this process will maintenance and monitoring. The schedule is here. They have to, it's cyclic process. They have to start it all over again every 3.5 years. But if they have new computer system during these 3 years, they have to do it again, the delta. Or whenever they have a new hazardous substance is added to the factory, they have to do it, the delta. So let's go to all the steps, step by step. I hope I will have the time to show all the steps. So first, preliminary steps. First of all, appointing a cybersecurity officer. They have 60 days to send us a name of person who is in charge. It doesn't have to be expert. It just has to be a point of contact that control the process and can report us. The second preliminary step is publishing a cybersecurity policy. In order to get management support, manage the resources, the human resources and the finance resources, we must meet the management or the board to write and to sign policy. So we get to step one. So in step one, and you can see here down all the steps, all the work planning. Now we are in step one, the red one, mapping a dangerous process and risk. They have to do the mapping, and from all the hazardous material they have in the factory, they have to choose the computer controlled and automated processes. If material is not computer controlled, I don't care about it in cyber aspects. Step two is the most important step, is to do risk assessment. So we know that risk consists of two components. First one is the impact. The second one is probability. You can call it level of exposure. So we have developed two Excel sheets. The first one is to calculate the impact in terms of pressure, radiation, and ppm, toxin in the air. You have to calculate the impact with chemical engineer or process engineer. And the other Excel sheet is to calculate the probability or level of exposure. You can do it with an IT staff, with a CISO, maybe a security officer, and of course the operation manager. So we have 36 questions here, and from the 36 questions you do the average, and you get a very accurate value for the probability. The same for the impact. You get a value from 1 to 4. 1 is the most dangerous, and you can get the value. And if you have the values for I and P, you can put them into this equation. This equation is took from actually Israel National Cyber Directorate. And we can calculate, I can explain later offline how we got to this equation, but it's work very good. It gives more emphasis to the impact, because we won't multiply it by 3. So we know the risk. We have a value for a risk. For example, if P equals 3 and I equals 3, so the risk will be 12. This is part of the Excel sheet that you have to calculate. You just have to ask the question in the factory, and by the answer, you know to rate the score here. You do it over 36 questions. This is the part of the Excel sheet in order to calculate the impact. I will not go over here the content here. You can read it in the cyber guide, but you can get from 1 to 4. 4 is actually danger to human life. People are dying from cyber attack. You are in 4 degrees. How do you calculate the toxin in the air? So we use the special criteria which called PAC, Protection Action Criteria. It came from the United States. We have PAC 1, PAC 2, and PAC 3. PAC 3 is potential of dispersal of hazardous substances with fatal impact. People not come back, they die. PAC 2 is some influence accompanied with irreversible damage. People can get back to life, maybe with some problems, but they can get back to life. And the PAC 1 is accompanied with reversible. We can calculate it with special software called Aloha. You can download it for free. You can put some input like atmospheric condition, location, container, shape and dimension, spreading algorithm, and then you can know exactly the recommended separation distances. You can export the details into Merplot software. You can see on the map where is the PAC 1, the yellow, Where is the pack 2, the orange, and when is the most dangerous area, the pack 3, people are dying here. I done something in Israel, you can see it here. On purpose, I deleted the places, and I found that in 11 meters, we have 200 ppm of very dangerous materials, and people are dying here. In 28 meter, irreversible damage to people. So we know how to calculate these things. Okay, I done the calculation and I know the risk. The risk is, for example, 12. So I look at the heat map. If the risk is equal 12, I know that I'm here in package level 3, and I know that I have to implement 81 controls. 81 controls. Which controls? I ask myself. Very easy. I go in the cyber guide. I have the list of controls. We have many kind of controls from 1 to 4. Green controls, level 2 controls, and level 4, the most in the most risky places, they have to implement also level 4 controls. The controls actually built from two concepts, two principles, the PPT model, people process technology, and from the 5 NIST CSF cybersecurity framework: protect, detect, identify, respond, recover. Everybody knows that here, I hope. Step 4, as I said before, gap analysis. We have to, we know the existing control, we know the required control, and we do the gap. And then we go to step 5. Step 5, we compile a compliance plan. We have to write this plan step by step, what I'm going to do in my factory. What is the required control? What is the status and action items? It must be like this. Step 6, you have to execute the program. This is the program. This is the execution on the keyboard, actually on the keyboard. You do the job. We are here, step 6. And last step, maintenance and monitoring. All this process must be monitored. We do some, so we're done actually with the regulation. If we done all these 7 steps, and we actually support, we have some regulatory support action. We're going to establish CISO for hazardous materials industry in Israel to give the factories eyes into the production floor. And we created a cyber course for the hazardous materials industry. It's in collaboration with the IMI, Israeli Manufacturing Association. You can see here from in the right, the publishing. I can tell that the first course, within 4 days of registering, the course was filled of 50 people. And we done 2 courses, July 2020, February 2021, and the next one is next month, July 5th, next cyber course, especially for hazardous materials industry. I have 5 minutes or 10 minutes. I will talk very quickly about the challenges, the key challenges. So we know that we have to do separation from IT and OT networks, but the big challenge is to make the CISO, which is in charge of the IT system, to work together with the operation manager. That he's actually the king of the production floor. Nobody can disturb him or the process. And it's very convenient to the CISO because the production floor is noisy, dirty, low technology. So the CISO give up. And my big challenge, and I'm going at least 2 or 3 times a week to the factories in Israel, my big challenge is to collaborate, to make cooperation between them. And it's done. It's done. Another challenge is a lack of experts, a lack of practices we need in order to be cybersecurity in ICS and SCADA. We have to know IT, we have to know IT security, about something about firewalls, about content filtering, WAF. We have to know something about OT, about what is controller, what is HMI station. We have to know something about the security of ICS. So we have to be here in the little red dot. We have to be IT and OT cybersecurity expert, but it's not enough for us in the Ministry of Environmental Protection because we need knowledge of hazardous materials. So I think that we're now building a new, job. Maybe we call it cyber ecologist. I don't know, but it's a special expertise. Very quick, some more challenge. Of course, the supply chain is the weak link of the chain. We have to take care of it. We have to monitor the OT network by SIM-SOC system. So that's why we are establishing the SIM-SOC for the industry. Of course, awareness tutorials, not for the IT staff, also for the OT staff, for the operation managers, engineers, HMI operators, mechanical, electrical engineering, all these guys. And procedures. We need procedures. It's a challenge how to do remote control into the OT network and so on. That's it. So I think that as a result of all this action, we will increase in Israel the resilience of the plant to high level protection. We're ready and I'm ready to share all the knowledge and all the experience with other countries, with other factories. You just can mail me, call me, and I'll be there. Thank you again for Jose, for Cybersecurity Observatory. Thank you very much.
Thank you, Yosi. Very interesting presentation. I am very happy to share this knowledge with the community. Actually, I propose you, if you want, at the end of the day, you're under control here. We will be sharing this presentation with the community. And if you want to share this methodology to include that in the Cyber Security Observatory, I invite you to do that. I'm happy to do that. You can, I'm more than, the observatory is a global project, and I think what we are seeing, the level of activity we have been witnessing, you guys know much more than, for example, I do. I remember 3 years ago, I was visiting the Israel Third in Beersheba for financial services, and I was talking to the head of the Third, and he was, it was a very educated discussion. When I go to Israel, I listen because, I don't know anything about almost anything, right? So, although I have been studying most of my life, but, when you need to listen, just listen. So I remember that at that time, the head of the Third told me that, they were in touch with, the leaders for cybersecurity from most of the big financial institutions, the systemic financial institutions all around the planet. The collaboration was very, very dynamic in financial services, so I think it's important also, to share this knowledge all across the planet, because at the end of the day, there are just two groups in the world, it's the good guys and the bad guys. That's it. It's simple. It's people who try to protect people and people who try to wreak havoc in our society. Right. So I think sharing this knowledge is very, very important, and I am committed to do so, leveraging our knowledge sharing platform all across Europe, the Americas, and also APAC. So if you want to share the knowledge, I put my infrastructure available to do so.
Yes, I love to do it. As you said, there is no countries. There is the good guys and the bad guys. That's it. I have the chance to be in a cyber tech in Dubai. We have peace relations between Israel and Dubai. And I share with them this cyber guide. Some guy call me and I explain him every page and every control. and I love to do it everywhere in the world because we're protecting our lives and the environment, of course, and the globe.
There is one question from the audience. The question is, we need to go super fast because we are overrunning the meeting. The question is, what is your methodology in differentiating accidents due to malfunctions when compared to the ones resulting from cyber attacks? For instance, due to my knowledge, Beirut incident is due to mistreatment of the materials. Would you elaborate on this?
That's right, that's right. Beirut is not example for cyber attack. Absolutely right. I put Beirut as example to show the scenarios that we're talking about. I talk about 3 scenarios. And in Beirut event, we have all the 3. It's not cyber attack, but very easily it could be cyber attack because every port in the world actually have this material, ammonium nitrate, because it's for the agriculture. So it was example not for cyber attack, but for the 3 scenarios in the same event.
Okay, thank you very much. This concludes the session. Thank you, Yosi. Thank you very much. Toda Rabba.
Thank you, and you're invited to come to Be'er Sheva and to see our SIMSOC place. I will love to invite you and to visit us.
I will gladly go. Thank you, sir.
You will be my special guest if you come.
Thank you.
Bye-bye.